In this video, we're going to learn how to check if a number is prime using recursion in Python. So a prime number is a natural number greater than 1, which is divisible only by 1 and the number itself. So for example, we could check if the natural number 6 is prime by checking if 6 is divisible by any of the natural numbers between 1 and 6. So for example, 6 divided by 2 is going to be 3, remainder 0. And 6 divided by 3 is going to be 2, remainder 0. 6 divided by 4 is going to be 1, remainder 2. And 6 divided by 5 is going to be 1, remainder 1. So here, 2, 3, 4, and 5 are the natural numbers between 1 and 6. And with 6 divided by 2, we have a remainder of 0. Because we have a remainder of 0, we would say that 6 is divisible by 2. Whereas with, say, 6 divided by 4, we have a non-zero remainder of 2. So we would say in this case, 6 is not divisible by 4. Now because we have a number between 1 and 6, which 6 is divisible by, we would say that 6 is not a prime number. Now let's check if 7 is a prime number by following the same process. We'll have that 7 divided by 2 gives us 3, remainder 1, and 7 divided by 3 gives us 2, remainder 1, and 7 divided by 4 gives us 1, remainder 3, and 7 divided by 5 gives us 1, remainder 2, and finally 7 divided by 6 gives us 1, remainder 1. Now in this case, all the remainders are non-zero, so we could say that 7 is a prime number. So let's build a function to solve this problem in Python. We'll call the function isPrime, and the function will accept the number itself as an argument, so we'll have the parameter number. Now we can solve this problem using recursion by having the isPrime function call itself. When a function calls itself to solve a problem, we call it a recursive function. Now the way a recursive function typically works is by solving part of the problem to be solved, and then calling itself to solve some smaller remaining portion of the same problem to be solved. Now what we need to do here is check if number is divisible by any natural number between 1 and the number itself. To check each of these possible numbers here, what we'll have is a parameter with a default argument value. We'll have that divisor is going to be equal to 2 by default. The idea is that we'll call isPrime and we'll just pass it the number. We'll have isPrime and say, for example, we'll pass it 6. Then divisor is going to be set to 2. And what we can do is call isPrime from within isPrime with an incremented divisor value to go through each of these numbers here between 1 and the number itself. So for example, we can call isPrime and pass it the number and then divisor plus 1. So each time we call isPrime, we can check to see if the number is divisible by the next number between 1 and the number itself. We can check for that using the modulus operator. So the modulus operator % will give us the remainder of a division operation. And if the number divided by the divisor gives us a remainder of 0, that tells us the number is not a prime number. So if this is true, we're going to return false because we've discovered the number is not prime. Otherwise, we're going to continue checking the numbers between 1 and the number itself by calling isPrime with divisor plus 1. And we'll check to see if number is divisible by one of those remaining numbers. And what we'll do is return the result of that check with return the return value of calling isPrime. Then we eventually want this recursion to stop. So once divisor actually reaches the number itself, that will tell us we've checked all the numbers between 1 and the number itself. So we'll check for that. We'll have if the divisor is equal to the number, This tells us we've checked all the possible numbers between 1 and the number itself. And if we never returned false, that means the number was not divisible by any of those numbers. So in that case, we're going to return true. We could now test this function out. So down here, we'll call is prime with 6, and we'll output the return value using print. Then we'll save our program and try it out. And we get that 6 is not prime, which is correct. Now, what about 7? We'll call is prime with 7. We'll save the program and we'll try it out. And we get that 7 is prime, which is correct. So this is how we can check if a number is prime using recursion in Python. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers.